In this video, we're going to be looking at one of the skills that we need in order to eventually start to solve equations. So we're going to learn how to simplify polynomial expressions. Now, a lot of the time, people say, I'm okay at math, but once you start to bring in letters and numbers, I get confused and I don't know what to do. It's actually not that different than stuff we do in our everyday lives. So I want to give you an example. I've got some images over here that I'm going to move around, but I want you to imagine that you're in a grocery store and you grab 3 apples. Okay, so I'm going to take these 3 apples over. There's 1, there's 2, and there's 3. And you add to your grocery basket another 2 apples. You realize you need a few more. Well, you already know how to do this kind of math, right? Because this is going to give you 5. But 5 what? Specifically 5 apples. So we're familiar with stuff like that. What if we talked about, okay, we went to the fruit aisle and now we actually need some bananas. So let's say I have 2 bananas. 1, 2. And I decide, you know what? I need to grab 5 more. Okay, so did I print some extra? 1, 2, 3, 4, 5. And I don't need this one. Well, what do we end up in our basket? We now have, and you can count it if you need to, 1, 2, 3, 4, 5, 6, 7. 7, and again, we don't just say 7. You've got to tell me what you have. So 7 bananas. Whoops. Bananas. So that's, I think, fairly doable for most people. So when we talk about math with letters, we're really just doing more of the same. But instead of us having to write the word apples every time, why don't we give it a letter? Maybe just the letter A. So I could say I have 3 apples plus 2 apples. A is just our short form for apples because maybe we don't want to write the whole word. And so that gives us 5 apples. And so that's the kind of math that we're looking at today. If I add 2 things like this, what's my answer going to be? So we're going to look at this for the rest of today's video. Similarly, for the banana example over here, I'm going to move these bananas down. And what I have is, let's say I use the letter B. Whoops, that's not what I meant to do. Let's say I want to use the letter B to represent the number of bananas. I have 2B, or rather, let B represent bananas. So 2B plus 5B, so I have 7 Bs. So again, that's all simplifying expressions is. Except eventually, we're going to start using x's. So for example, I might do 2x plus 5x. Well, now I have 7 x's, but I'll get to that in a second. There's something else that we want to introduce you to, and it's the idea of like terms. So let's say I had a new statement. Let's say I said, I've got 3 apples in my basket. I go and I grab another 2 apples. And in that same basket, I have 5 bananas. And then I go back for another 2 bananas. Well, how are we going to add this? Well, we can't add apples and bananas together, but we can say I can add these so that I've got 5 apples. And I can add these so that altogether I have 7 bananas. Okay, but we have to stop there because I can't add apples and bananas together. I mean, I could say that I have 12 fruit, but now all of a sudden that's a whole different thing that I'm talking about. So I want to introduce you to the concept of something called a like term. So a like term are things that have the same variable and the same exponent. So for example, in this question here, these are like terms. They're different from these, but these are also like terms of one another. Let me do this with more mathy terms. So I could rewrite this as 3a plus 2a plus 5b plus 2b. These are now what we call like terms. Okay, and these are a different set of like terms.
So before I keep talking about this thing called like terms, let's just quickly go over what a term even is. So a term consists of generally a number and a letter, and sometimes that letter has an exponent attached to it, but let's not get into that just yet. So a term would have a few components. This big number in front we call a coefficient, and that's just a fancy word for the front number of the term. This bit here, the letter, is what we call the variable. And again, like I said, sometimes the variable can have an exponent, but we'll get to that a little bit later when we talk about different types of like terms. So when we say look for like terms, or these terms are like terms, we're talking about saying, well, this is one term here, here's a second term here, and because they have the same letter, because they're both talking about, in our example, apples, these are like terms. They're similar, they're like each other. Whereas if I took 2a and I compared it with 5b, these are each two different terms, but they're terms that are unlike because this portion here is different. Okay, so hopefully you're able to see what a term is. Basically, each term, if I've got it linked together with a number of different things, each term is separated by a plus or minus. So in this question here, if I don't simplify it, I'm just looking at the way it's written here, I've got 1, 2, 3, 4 terms. These two were considered like terms. And so 3 apples plus 2 apples gave us 5. 5 bananas plus 2 bananas gave us 7 bananas. And so that's how we did that. But again, this is just to clarify a little bit about what a term even is before we go into more depth about what a like term is and what an unlike term is.
If you found this video helpful, please like and subscribe.